Hi, and welcome back. What you're looking at right now is Franklin the cat, and we also have with us here tonight Midnight on the other side, and they'll be assisting us this evening. Ariana is asleep. Okay, so we are going to be talking today about section 10.2, which are the sum and difference identities. And here's like a question that I want to start with here. The question is, can we distribute the cosine part of the cosine function through parentheses? So in other words, if I have cosine of a minus b, in other words, I have two angles inside the parentheses, is it okay for me to take that cosine function and distribute it through the parentheses? In other words, is cosine of a minus b equal to cosine of a minus cosine of b? That's the question that we want to start with here. Okay. All right, so if this is true, if we're allowed to distribute that cosine function through the parentheses, then this equation should be true no matter what a and b, no matter what two angles I choose. So I'm going to look at an example and just kind of look at this example as a test. So let's say that our angle A is 45 degrees and angle B is also 45 degrees. Then let's take a look at what cosine of a minus b would be. Well, we'd plug in 45 degrees for a and 45 degrees for b, so we'd have cosine of 45 degrees minus 45 degrees. And so if I simplify inside the parentheses, I have cosine of 0 degrees. And if I was a rock star with my cosine functions right now, I might know that cosine of 0 degrees is equal to 1, but if I maybe hadn't thought about my trig values in a little while because we've been doing identities for a few days, 0 degrees is one of our quadrantal angles, and so I can mark that on the xy axis, and that point is the point 1, 0. And so if I think about that point on the unit circle, the x value is our cosine of 0 degrees and the y value is our sine of 0 degrees. So the cosine of 0 degrees is equal to 1. Okay, so that is cosine of a minus b, and let's compare that to cosine of a minus cosine of b. So our a value is 45 degrees, so we have cosine of 45 degrees minus our b value, which is also 45 degrees, so minus cosine of 45 degrees. And cosine of 45 degrees, I might remember that that is square root of 2 over 2, but if I didn't remember that, then I could draw out the 45-45 right triangle. And our cosine of 45 degrees is adjacent over hypotenuse, 1 over root 2, and then I rationalize, and I get root 2 over 2. Okay, so cosine of 45 degrees is root 2 over 2, minus cosine of 45 degrees, which is also root 2 over 2. And so root 2 over 2 minus root 2 over 2 is 0. Okay. So what did we just do? We figured out that cosine of a minus b for our a and b example is equal to 1, but cosine of a minus cosine of b gave us 0. What that means is cosine of a minus b is not equal to cosine of a minus cosine of b. I am not allowed to distribute this cosine through the parentheses. Okay. In fact, I mean, quite honestly, you probably knew that ahead of time, because if we were allowed to do things like distribute the cosine function through the parentheses and that was a legitimate math thing to do, well, if we could have done that, we wouldn't have an entire 3-credit course on trigonometry if working with these functions was that easy. Okay. All right. So big note up here on the board is that cosine of A minus B is not equal to cosine of A minus cosine of B. Okay, so no matter how tempted you are to distribute that trig function through the parentheses, do not do it. All right, so that's great. So now we know what we're not allowed to do. The next question is, well, if that's the case, is there an expression that is equal to cosine of A minus B? Okay. And the answer to that is yes.
Can't see the red.
That's okay. If you can't see this, then you should definitely write it down in your paper, put a big not equals into it, and say cosine of A minus B is definitely not equal to cosine of A minus cosine of B. All right, so the question is there an expression that is equal to cosine of A minus B? The answer is yes, and I'm going to tell you what that expression is. Here it is. Cosine of A minus B is equal to the cosine of A times the cosine of B plus sine of A times sine of B. And what I've just written down up here on the board is the difference identity or difference formula, the difference identity for cosine. So this is called the difference identity because we're subtracting inside the parentheses, and it's for cosine because this is the cosine function. Okay. Now, I just totally pulled this out of thin air. Okay. There's no reason that you should look at that and say, oh, well, of course that's the formula for cosine of A minus B. There is absolutely no reason that you should have any idea where this formula came from. In fact, the second portion of the lecture tonight, I'm going to do on the whiteboard format, and we are going to derive this formula. We're going to talk about where it comes from. But for right now, for this half of class, take this as here's our formula, and we're going to work with it. Okay. Okay. So the next question is, why do we care? Why do we even care about this formula? Well, there are a couple of reasons. One of the reasons that we focus on this formula has to do with this idea that if you're just kind of hanging out with trig functions and you haven't spent a lot of time with them, it is really easy to try and do things like distribute through the cosine function through the parentheses. And I cannot do that. I cannot take this cosine that's in the front and apply it to both terms inside the parentheses. And so this entire day is hopefully an emphasis on that fact that by working with these identities, that you hopefully will remember that you're never, ever, ever allowed to take the cosine function and distribute it through the parentheses. Same is true for sine or tangent or any of the rest of them. Okay, so that's one reason we care, is to emphasize the properties of our trig functions. Now, this might seem a little bit strange to you because when we have algebraic properties, things like let's say you have x times 5 minus x squared. There, it's totally okay to distribute through the parentheses and write this as 5x minus x to the third. So distributing is totally fine. On the other hand, in your college algebra class, you learned about another type of function called the natural log function, where you might have had something like natural log of a minus b, and this one you are also not allowed to distribute. And you may have learned some properties of natural logs, such as here's a property where you can do things. Natural log of a times b is natural log of a plus natural log of b. And so you spent a lot of time with this natural log function learning about the properties and how to properly deal with that natural log function. And that's kind of what we're getting at with this particular class period and our trig functions, is what are some of the things that we're allowed to do with the trig functions? How do we adapt to the new properties of these trig functions? So that's one reason that we care about these difference identities. A second reason that we care about these difference identities and these sum identities is because when you hit calculus, you will occasionally be running into these difference identities, and so you want to be familiar with them and see them before you jump right into one of your calculus classes. And the third reason, which maybe is not the most important reason, but is a reason for talking about these sum and difference identities, is that these sum and difference identities allow us to calculate trig values for more angles than we could before. So far, when we talk about calculating trig values for special angles like 30, 45, and 60, that's great, but that's really not that many angles that we can calculate trig values for by hand. And these sum and difference identities are going to give us another collection of angles that we can work with. Okay, so let's talk about an example of using this formula. So we would like to find a value for cosine of 15 degrees without a calculator. Meaning we're going to find an exact value, and we're going to do this without typing it into the calculator. Okay, so 15 degrees is definitely not one of our special angles. Our special angles, as I just mentioned, our special angles are 30 degrees, 45 degrees, and 60 degrees. And you could also include as special angles the quadrantal angles. They won't really play a role here. You could also include angles that are part of the unit circle where the reference angles are one of these three angles. But these are our main special angles. Okay, so the question that we ask ourselves is, can I take two of the special angles and subtract them to get 15 degrees? And the answer is, yeah, I can do that. And if we were in class, I'd have you turn to your neighbor and say hello, and tell your neighbor one way that you can combine two of these angles up here by subtracting to get 15. All right. And after you've talked to your neighbor, since you don't have a neighbor, you might talk to your pet at home, or maybe, you could call into the other room to the rest of your family members and tell them one way to write 15 degrees by subtracting two of these angles. There are a lot of different ways to do this. Two of the ways are, we can look at it as 60 degrees minus 45 degrees, or we can look at this as 15 degrees equals 45 degrees minus 30 degrees. Okay. Now, for our example, I am going to choose 60 minus 45. I would encourage you to also try the 45 minus 30 and make sure that you get the same answer. Okay, so our goal is to calculate cosine of 15 degrees. So cosine of 15 degrees. And the way that I'm going to write that is, instead of 15 degrees, I'm going to write down cosine of 60 degrees minus 45 degrees. And so the way that we're going to be using this formula, which I've left up here on the board, is that our 60 degrees is playing the role of the A in the formula, and the 45 degrees is playing the role of the B in the formula. So when I plug things into the formula, our formula says cosine of A, so that will be cosine of 60 degrees, times cosine of B, so that will be times cosine of 45 degrees, plus sine of A, so that's sine of 60 degrees, times sine of B, which is sine of 45 degrees. So this is actually kind of cool because I have no idea how to calculate the cosine of 15 degrees from one of our triangles, but what I do know is I know I can figure out the cosine of 60, the cosine of 45, the sine of 60, and the sine of 45. I might have those completely memorized. If I don't, I might draw some pictures. So here's our 30-60 right triangle with our 60 degree measure here, and my sides are 1, 2, and square root of 3. And here's my 45 degree triangle. And this is how I like to think about calculating these trig values, but you may like this, or you may have a photographic memory and you might have these memorized, or you might use the unit circle. Any of these are good ways for writing down these trig values. But what you want to be able to do is you want to be able to look at this and say cosine of 60, I can figure that out. So cosine is adjacent over hypotenuse, so we have cosine of 60 is 1/2. Cosine of 45, well, that is adjacent over hypotenuse, 1 over root 2. When we rationalize that, we have root 2 over 2. Sine of 60 is opposite over hypotenuse, so that's root 3 over 2. And sine of 45, opposite over hypotenuse, so 1 over root 2, rationalized is root 2 over 2. So now we have everything in terms of numbers, and my last few steps are going to be to clean this up. So when I multiply these first two fractions, I multiply across the top and I have root 2. Multiply across the bottom, 2 times 2, I have 4. Then I have a plus sign. Multiplying across the top, root 3 times root 2 is square root of 6. In the denominator, 2 times 2 gives me 4. Okay, so now I have two fractions. They already have a common denominator, so I can combine them into square root of 2 plus square root of 6 divided by 4. And so what I've just calculated is that cosine of 15 degrees is equal to root 2 plus root 6 over 4. And you can double check that if you put your calculator in degree mode and type in cosine of 15 degrees, you'll get a decimal approximation. And if you type in root 2 plus root 6 divided by 4, you should get the exact same decimal approximation. Okay, we're going to pause here and we'll come back for the second part of lecture 1.